Hi everyone, and welcome back to Education with Eleanor. In this example, we're going to learn about EMF, or the electromotive force, and how it relates to magnetic fields. So what will happen is that before we've learnt from the right hand grip rule that a current has its own magnetic field. Okay, so a current has its own magnetic field. So if you think about it in a backwards, if you've got something that's moving, like a piece of metal moving through a magnetic field, then you can actually induce a current, and the current will also have a voltage or electromotive force, also known as EMF. So that's where this is coming from. So if we have a rod that's 15 centimeters long and it's moving at right angles to a magnetic field. Now let's assume it's going to the right and our magnetic field is going down the page. So we have everything is at perpendicular. So the movement of the rod is perpendicular or at 90 degrees to the direction of the magnetic field. And this magnetic field has a field strength of 0.30 Tesla. And this rod is moving at a speed of 60 centimeters per second. Now, the first thing we need to do before we do anything else is make sure everything is in SI units. Now, that velocity is in centimeters per second, so we need to divide it by 100 to get it to meters per second. Now that can be written as also 60 times 10 to the negative 2 meters per second. And this length of the rod, we can do the same thing. So we know that the rod is 15 centimeters, so 15 divided by 100 will give you what you want, or it's 15 times 10 to the negative 2 meters for the length of the rod. Now, the next part is we need to actually know where our equations come from. So, we know that work is also the force multiplied by the displacement or distance, and then that's also the same as Q, which is the charge of a charge of a particle multiplied by the velocity multiplied by the magnetic field strength, and then this distance is also known as the length of the rod. So that's how much energy is needed to move an electron along. That's how we calculate it. Now, just to make sure we understand, the force from a magnetic field is the charge multiplied by the velocity multiplied by the field strength, and then that distance, we're going to highlight it in green. That's the length of the rod. And we'll highlight work in and of itself in orange so that we can keep remembering this. Now let's keep going. We know that the EMF induced, the electromotive force, is given by the work to move the electric charge or electrons divided by the charge of the particles. Now, we're going to substitute our work equation in. So the EMF is given by, in the numerator, QVBL divided by Q. The charges cancel out to 1. So the EMF is given by the velocity multiplied by the magnetic field strength multiplied by the length of the rod. And that's how we calculate the electromotive force induced, or the voltage. So E equals VBL. So the velocity, also I forgot to say, we often see it as magnetic force, the electromotive force is known as the magnetic field strength multiplied by the length of the rod multiplied by the velocity at which the rod moves. So this is how you commonly see it. So the magnetic field strength is 0.30 Tesla. The length of the rod is 15 times 10 to the negative 2 meters, and the velocity of the rod is 60 times 10 to the negative 2 meters per second. So the answer for this is 2.7 times 10 to the negative 2 volts. This is the same as 0.027 volts or 27 millivolts. Now, these are all in two significant figures, so any three of these versions of this equation can be used. So that is the voltage or the electromotive force induced by the magnetic field in the rod. Alright, so that's how you calculate how much EMF is induced when a magnetic field has a rod or a current conducting object moving through it. So that's the voltage that is induced, and it's because the magnetic field induces a current in that rod, and the current has an associated voltage or electromotive force. This has been Education with Eleanor, and press the thumbs up if you liked this, as well as hit the notification bell so you can subscribe and get notifications on more mathematics, science and physics videos. See you next time. Bye.